given here, which is the weight, we will try to find the minimum cost, okay, and to help this, in order we can use this Prim's algorithm to find the plan for this town paving. So for the vertices here, we will do the same like just now. Now I think some of you maybe you know straight away that if I look at the graph like this, straight get the answer, isn't it? Right? From the weight given here, I can straight away choose which one is the minimum, and I can straight away get the minimum spanning tree with the minimum total weight. Of course, this is a simple graph. Now, we only do it manually. We didn't do using the algorithm to write the program, because in this course, we only want you to know the concept. So when you do it manually, it is impossible for us to give you a complicated graph. Okay? So what we have here is the algorithm for you to follow. So even though this graph is simple, you can straight away get the minimum weight, but what I want to see is the steps that you do. So you need to follow the steps that I show you just now by constructing all the tables one by one and insert the vertex one by one for the Prim's algorithm. Okay, so don't straight away give the final answer of the minimum spanning tree. So I will tell you here first, because I have seen before this, some of the students, they straight away give the minimum spanning tree with the minimum total weight without any steps. So what we can give is only the final marks of the minimum spanning tree. If you do like that, you need to show your steps like just now I showed you like this. Of course, this one you don't need to write so many words. You just form the table and then circle it, write which weight you choose. Enough already. Okay? You know what I mean? Can I? Okay. So you try to do this one. Follow what we say just now, and for this you can choose any of your root. Not necessarily we must start with the same root. Maybe some of you want to start with E, some of you want to start with A, you want to start with H. It's up to you. Finally, you will get the same minimum total weight. No worry. If you get different, then maybe your answer is wrong. Okay? If your answer is correct, you should get the same weight. Do it.
Maybe.
Okay, so you write in your paper the steps that you do just now. Follow which one you can do. So I can put the table here, referring to the graph. So you want us to do together or you want to do yourself? Okay, which one you want to choose as the root? Different already. H or A? Majority who want to choose H? H? Who want to choose H? Okay, where is the H one? A? Who want to choose A? Why want to start from A? Huh? You can choose different one, right? Not need every time choose. Okay, never mind if you want to choose from A. Now, A, you have B, C, D, E, F, H. Okay, B, C, D, E, F, G, H, right? Now, if you don't want to write all, also never mind. You can just write whatever that is connected to A. You can do like that also. Okay, but later on you need to add. So A connected to B and C. So B is 3, C is 2. Okay. AC. Yes. So now the next table will be A, C. So here we will have B, D, E, F, H. Okay. A go to B 3, C go to B also 3. C go to E is 5. go to
F5.
any more? No more, right? Okay, so minimum is
AB or CB.
是要吃樱桃跟大草。
which one you want to choose?
我已经读了，因为我要喊了。
A, B or C, B? You want to choose? C, B. Okay. Then A, C, B. Okay. So here left D, E, F, G, H. So A to no more.
Our
C to
EF.
E, F. Five.
其实他是狠人呢。
D to
D.
你看，他绝对是个狠人。
B to D is 2. Right?
D.
Okay. B to D is 6. Then B to no more, right?
No.
Okay. So minimum
他先把自己
EE or
跟老
F.
师每个人比处。
CE or CF? Which one? CE or CF?
他们会因为，哎，他美术生美神奇，应该是他不会。
Nobody choose, I choose. So CE, ah? 5, ah? Okay, now I write here. So you have A, C, B,
E.
E. So D, F, G, H. So C to F5.
B to D6.
Yes. E.
E to D2.
E to D2.
E to F4.
E to F4.
E to D3.
Okay. That's all right. Okay. Minimum.
ED2.
Yes. So now we have A, C, B, E, D. So here is F, G, H. CF 5. BD
D no more.
E,
No more.
EF
4.
4. EG 3. D,
DH2.
DH2. That's all right.
Yes.
Okay, minimum
DH2.
2. So we have ACBE.
DH.
So here we'll have
FG.
FG. So CF 5. The EF 4. EG 3.
HG6.
HG 6. Minimum
EG3.
EG 3. Okay. So the table now will have A, C,
HG.
DHG. So left F, right?
Yes.
So we have CF 5, EF 4. G got or not?
GF4.
GF 4. Which one we want to choose? EF or EF or GF?
笑人，很积极。
Just now we choose CE, CF. Just now we choose CE. Right? So now you can choose EF or EG. Okay, let's say we choose EF. Then no more already, right? So we will draw this AC, CB, CE, ED. So refer to the graph here. The first one we will have AC. So our graph will be A to C, AC, and then BC. AC is 2, BC is 3. C, CE, right? 5, followed by ED. ED is 2,
DH,
DH also 2,
EG,
EG is 3,
EF,
last one is EF4. Okay, we get this. One of the minimum spanning tree you can get is this. Of course, just now you can see there are many alternatives, right? So if you choose that alternative, you will get different also lah. But the weight, if you add up the minimum total weight, it should be
21.
21. Yes. The question asks to find the plan of the town paving, so we just write the minimum total weight is 21. Okay? Understand the Prim's algorithm? This one? Any question? So these are the steps that you need to do for the Prim's algorithm with weight. Now, as I say, sometimes the weight is not given. They only give you the graph. So the undirected graph. So that means you need to find for the minimum spanning tree also. Like just now, I give you this one. You try to remove the edges, right? This one. So you try to remove the edges to get the spanning tree, isn't it? So we can do this actually by using the Prim's algorithm also to get the minimum spanning tree if the graph given is no weight. So we can do both, whether with weight or without weight. So now we look at the graph if there is no weight. Now I hope you still remember if you have 0 or 1 in the matrix, how do you want to combine it? Last time, how do you do when you do the logic? 0 or 0 is?
0,
0 or 1 is?
1,
1 or 0?
1,
1 or 1?
1.
Okay, we will use this concept to combine the vertices that is connected to each other. So now we look at the example here. This graph has no weight. So this one, you have connected graph here, and we will try to find what is the minimum spanning tree. A simple graph only, Okay. Now, first thing we need to do is we need to convert this to a matrix. When we convert this to a matrix, we will just look at which vertex is connected to which one, then we will put it as 1. For example, this one A is connected to D, so we will write A to D is 1. A connected to C, so here is 1. Is A connected to B?
No.
No, so we will put it as 0. B connected to
C and D.
C and D, so these two are 1. C connected to
A and B.
A and B, so these two are 1. And D connected to
A and B.
A and B also, so we have this matrix. Okay, now for the Prim's algorithm, what are we going to do is we will try to combine the vertex here, A, B, C, D, until we get a single vertex. For example, when I want to start with, the question say with a vertex A as the root, so that means we will start with vertex A. If they say C as the root, then you start with vertex C. Okay, so now we will start with vertex A to combine with the other vertex here, where you can see that A is only connected to C and D, which means if you want to choose which vertex to combine with A, you can only choose the vertices which are connected to A. You cannot choose B because B is not connected to A. So you can choose either C or D. Okay? So now if I want to combine, I choose C to combine with A, then now A and C will become one vertex in a bracket like this. Instead of 4 by 4 now, the matrix will become 3 by 3. Okay? So A and C now becomes one vertex already. Now, if we want to combine the matrix, you look at this, A and C becomes one vertex. So AC to AC here must be 0. Because if it is a 3, it must be irreflexive. Right? So AC cannot go back to AC. But for the column B, you can look at the column B here. When I want to combine the row A and row C, this one is 0 and this is 1, A and C. So we will combine it using OR, like just now I asked you, 0 or 1. So 0 or 1 is 1. Come to the row column D. So the column D, same also, we will combine the row A and C. So here is 1, C is 0, so 1 or 0, 1. Okay, that is how you get the first row. And for the second row here, B, row B, you look at the row B, and the column A combined with the column C. So this column A here will combine with the column C here with 0 or 1 also. So here 0 or 1, you will get 1. B to B is 0, B to D is 1. And same also for the row D, you need to look at the column A combined with the C again. So 1 or 0 is 1. D to B is 1. B to D is 0. So now this is the reduced matrix after you combine the vertex A and C. Okay? Now the next steps still the same. Follow this algorithm. Continue to combine the AC with B or D. Either one. So if let's say now you choose B, that means the ACB will become one vertex, only left D. So now we have 2 by 2 matrix. Okay, look at this ACB, 0. So under the column D, you have AC combined with D. So AC is 1, D is 0. So 1 or 0 is 1. Right? Under the row D, you have AC combined with B. So 1 or 1 is 1. D to D is 0. Okay? Now, the last step is to combine ACB with D. So, we only left one vertex here, which is A, C, B, and D. Now, when you want to draw the minimum spanning tree, there are many ways that you can draw referring to the combination that you have just now. So if your root is A, you start from A, you can go to C, this one, A to to C, C to B, B to D. So your spanning tree will become A to C, C to B, and B to D. This is one of the spanning tree you can get. A to C, C to B, and B to D. Now, as you know, it is not necessary we can have this only. As I told you, you can try any other spanning tree. For example, what other spanning tree we can have? If just now we combine start from A to D, then you can have another spanning tree which is A to D, this one A to D, and then D to B, B to C. This is also possible, right? A to D, D to B, B to C.
Yeah, again. 哎，完了。这个 yes， 放学。
What else? Any others? FCBD, ADBC. Okay. Now, if this is the possible spanning tree that you can have, sometimes you will ask, is my spanning tree correct or not? Now, you no need to, you can check actually whether your spanning tree that you draw is correct or not by changing this to the matrix again. You can convert this to matrix form and you see what happened in your matrix. You see here, there is a matrix for you to fill in. So let's say I use the first spanning tree to fill in the matrix just now. So here I have A to C. So AC will be 1, CB 1, BD 1, right? This one, AC, CB, BD, yeah? So in the matrix here, I will have AC, CB, and BD. That means this will be 0. Okay? Now, in the matrix that I draw just now, if I convert, in the graph that I draw just now, if I convert to the matrix, what we can see is the column beside the root, there can only have 1, 1. Every column, there can have at most 1, 1. Okay? Beside the root, because the root should have no in degree, right? The root now is A. So they have no in degree for A. Other than the root, you see the column B, C, D, they can have 1, 1. Then your spanning tree is correct. If you try the second one that you draw just now, this is A, D, D, B, and B, C. So you have A, D, D, B, and B, C. So here also 0. Then you can see, besides the vertex A, all the other B, C, D, they can have the most 1, 1. Then the spanning tree you get is correct. Okay? So you can try. If let's say you are not sure your spanning tree after you draw, that is a correct spanning tree or not, then you just check using this method. If you see that all the other vertices, the column here that have at most one, then it is correct. Of course, your root cannot have one. Okay, any question for this Prim's algorithm without weight? Okay, understand how to combine the matrix or not? Okay. You need example some more? Need. Okay, let's say we have another graph. We have the graph here with A. This one quite A, B, C, D, E, F. Then your matrix will be very big. Okay, here you have A, B, C, D, E. 5 vertices. If you convert to the matrix, then you will have 5 by 5 matrix. A to E column and row also A to E. Okay? Then we just connect which one is 1. So you will have AB, AD is 1. This one, here 0. For the B, you have A and C and E, B, C, E. So this is 1. For the C, you have B on E. And for the D, we have A and E. For E, we have B and D. Right? This is the vertices that is connected in the graph given. So now, we do, because I already put the A as the first row, so we choose A as the root. But actually, if let's say the question asks you to choose the C as the root, you can always put the C as the first row and the first column. It will be easier to combine later on. Okay?
Wait, it's not B to B, but B to A.
Eh? Oh, yeah. Thanks. See anything wrong or not here? B to A. Any others? BA, BC, BE. Then A to B and D, C to B only, D to A and E to B and D. Okay? Now, if let's say I choose the A as the root, so now I will combine the A with either B or D, because B is connected to A and D also connected to A. So I can choose B or D. Which one you want to choose?
D.
D. Bang D, yeah? Okay, let's say we choose D. So here you will have AD in your first row also. That means the column here will only left B, C, E. B, C, E. So now the matrix will become 4 by 4 already. And look at the first row AD here. It is under the row A, column AD. This one must be 0. Okay. And under the column B, you have the A combined with D. So 1, 0 is 1. Under the column C, you have 0 or 0. A 0, D also 0. So we have 0 here. E, you have A 0, D is 1. So 1 under the column E. Right? Can follow? This one under the column B. So you look at the column B, the row A is 1, the row D is 0, right? So you combine the 1 or 0 under the column B to get 1 here. Okay? Under the column C, you want to combine the row A and row D, right? So look at the row A is 0, row D is 0 also. So 0 combined with 0, you get 0. And under the row E, same also. Row A is 0, row D is 1. So you will combine 0 or 1, you get 1. If don't understand, let me know. Raise your hand. Don't be shy. So the next row is B to AD. What is B to AD? Give me the answer. 1. A and D combine. Then B to B.
0.
0. B to C.
1.
1. B to E.
1.
1. C to AD.
0.
C to B.
1.
C to C.
0.
C to E.
0.
Okay. E to AD.
1.
1. E to B.
1.
1. E to C.
0.
0. E to E.
0.
0. Okay. Now we have 4 by 4. The next one is combine the AD with B or E. So you want AD with B or AD with E? B, AD with E or B? E or B? B. So ADB here, ADB here. This one is ADB. So here left C and E. Here ADB. Here C and E. Okay, ADB 0. C under the column C, you have AD combined with the B here. So look at the row AD is 0, B is 1. So 0 or 1 is 1. Row column E, AD is 1, B also 1.
1.
1. C to ADB,
1.
C to C,
0.
C to E.
0.
Okay, E to ADB,
1.
ADB 1. E to C,
0.
E to E.
0.
So continue. You have A, D, B, C. This one, A, D, B, C. So here left E, E. 0. E is ADBC. 1 or 0 is
1.
1. E go to ADBC. E, ADBC.
1.
1. E to E.
0.
So we have last one, which is ADBCE. This is the last project. Then you can draw your spanning tree, follow this. You can have AD and then DB. Now we don't have DB, we cannot draw D to B. So remember, when you draw this, you cannot exactly follow the sequence like this. You need to see the spanning tree you have, whether it is connected or not, because when you do the matrix, it will change this to 1. A, D, and to B, it becomes 1. But original graph, you don't have D to B. So when you draw the spanning tree, you cannot create the extra line from D to B. Okay? You still need to follow this original diagram. So to A to D, you can draw. This one no problem, you can follow A to D. That D to B cannot. So you need to draw from either A to B or D to E. Okay? So you can draw A to B and then B to C. Then D to E. B to E or D to E. Okay, from here, you see here, either you draw from D to E or B to E. So this is one of the spanning tree you can have, and you have all connected A, B, C, D, E with how many remove? 1 only, right? Okay, 1 edge remove. So if you convert to the matrix, you can see that all the vertices will have in column at most 1, 1. So this is one on the spanning tree. Maybe you can have others like A to B, A to D, A to B, B to E. This is also possible. AD, AB, BE, BC. Okay, and many more. So you can have also DE, EB, BC, BA without AB, or you can have AD, DE. You can remove AB, so you will have AD, DE, EB, BC. Another possible spanning tree.
可能迫不及待啊。
Okay? So the tutorial question, you have this type of trims algorithm also. You can try to do lah. Any other question for this? No, So we only left the Kruskal algorithm. So I will continue that one next week. Next week, lecture for the last part and also chapter 2 lah. So you just try the tutorial until trims algorithm first. Okay, thank you class.
那我们做这个信息，这个顺序，
没有意义。什么东西？什么？是啊。
按照前面的。
数学课你以为打瞌睡？